The National Electrical Code (NEC) dictates specific requirements for electrical installations to ensure safety and prevent hazards. When dealing with receptacle installations in commercial buildings, it's crucial to adhere to these codes to avoid potential problems such as overheating, fire hazards, and code violations. The question of whether 15-amp receptacles can be used on a 20-amp circuit in a commercial building is directly addressed by the NEC. The answer is no. You cannot use 15-amp receptacles on a 20-amp circuit in a commercial building. The fundamental principle governing this rule is that the ampacity of a branch circuit must not exceed the ampacity of the lowest rated component of that circuit. Ampacity refers to the current carrying capacity of a conductor or device, measured in amps. In simpler terms, it's the maximum amount of electrical current that a component can safely handle without overheating or failing. In this scenario, the 15-amp receptacle is the lowest rated component of the circuit. Therefore, the ampacity of the circuit must not exceed 15 amps. To elaborate further, consider a typical 20-amp circuit. This circuit is designed to safely deliver up to 20 amps of electrical current. If you were to install a 15-amp receptacle on this circuit, you are introducing a component that is only rated to handle 15 amps. If a load exceeding 15 amps is plugged into the 15-amp receptacle, it could potentially overload the receptacle, causing it to overheat and potentially start a fire. The NEC regulations are in place to prevent such scenarios and ensure the safety of the electrical system. To comply with the NEC, you have a couple of options. Firstly, you can use 20-amp receptacles on the 20-amp circuit. 20-amp receptacles are designed to handle the full 20-amp capacity of the circuit. This ensures that the receptacle is capable of safely delivering the maximum current that the circuit is designed to provide. Secondly, you can reduce the breaker size to 15 amps. If you need to use 15-amp receptacles, you can reduce the breaker size on the circuit to 15 amps. This effectively limits the amount of current that the circuit can deliver to 15 amps, which is within the safe operating range of the 15-amp receptacles. However, it's important to note that reducing the breaker size will also reduce the overall capacity of the circuit. This means that you won't be able to plug in as many devices into the circuit without tripping the breaker. When selecting the appropriate receptacle for a given circuit, it's crucial to consider the types of loads that will be connected to the circuit. For general-purpose circuits that will be used to power a variety of different devices, 20-amp receptacles are often the preferred choice. This provides a greater degree of flexibility and ensures that the circuit can handle a wider range of loads. However, for circuits that are specifically designed to power low-current devices such as lamps or small appliances, 15-amp receptacles may be sufficient. In such cases, it's still important to ensure that the breaker size is appropriate for the receptacles being used. In addition to the ampacity requirements, the NEC also specifies other requirements for receptacle installations. These include requirements for grounding, wiring methods, and box fill. Grounding is essential for providing a safe path for fault currents to return to the source. This helps to protect against electric shock hazards. Wiring methods refer to the types of conductors and cables that are used to connect the receptacles to the circuit. The NEC specifies different wiring methods for different types of installations. Box fill refers to the amount of space inside the electrical box that is occupied by conductors, connectors, and devices. The NEC specifies maximum box fill limits to prevent overheating and ensure that the electrical connections are properly made. It's also important to note that the NEC is a living document that is constantly being updated and revised. It's essential to stay up to date on the latest changes to the code to ensure that your electrical installations are in compliance. The NEC is typically updated every 3 years. There are several resources available to help you stay up to date on the NEC. The National Fire Protection Association, NFPA, which publishes the NEC, offers a variety of training courses and publications on the code. Additionally, many electrical contractors and inspectors offer continuing education courses on the NEC. In summary, the NEC prohibits the use of 15-amp receptacles on 20-amp circuits in commercial buildings. To comply with the NEC, you must either use 20 amp receptacles on the 20 amp circuit or reduce the breaker size to 15 amps if you need to use 15 amp receptacles. It is important to always consult the latest edition of the NEC and follow all applicable local codes and regulations when performing electrical work. Always prioritize safety and ensure that all electrical installations are performed by qualified and licensed electricians. Understanding the specific articles within the NEC that address receptacle installations can be beneficial. These articles provide detailed guidance on the requirements for receptacle spacing, height, and location. Article 210.52, for example, covers receptacle outlet requirements for dwelling units, but it offers insights into general receptacle placement principles that can be adapted to commercial settings. Article 406 addresses the general requirements for receptacles, cord connectors, and attachment plugs, including ampacity ratings and grounding requirements. Furthermore, understanding the specific requirements for overcurrent protection is crucial. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the maximum overcurrent protection rating for different types of conductors and equipment. For example, a 14 American wire gauge (AUG) copper conductor is typically protected by a 15 amp circuit breaker, while a 12 AWG copper conductor is typically protected by a 20 amp circuit breaker. When selecting overcurrent protection devices, it's essential to ensure that the rating of the device is appropriate for the conductors and equipment being protected. Using an overcurrent protection device that is too large can allow excessive current to flow through the circuit, which can lead to overheating, fire hazards, and equipment damage. It is also important to understand the concept of continuous loads. A continuous load is a load that is expected to operate for 3 hours or more at a time. The NEC requires that the overcurrent protection device for a circuit supplying a continuous load be rated at not less than 125% of the continuous load. For example, if a circuit supplies a continuous load of 16 amps, the overcurrent protection device must be rated at not less than 20 amps. 16 amps multiplied by 1.25 equals 20 amps. This requirement is intended to prevent the overcurrent protection device from tripping due to the heat generated by the continuous load. In addition to the NEC, local codes and regulations may also apply to electrical installations. It's essential to check with your local building department to determine the specific requirements for your area. Local codes may be more stringent than the NEC in some cases. Furthermore, it is important to use appropriately rated tools and equipment when performing electrical work. This includes using insulated screwdrivers, pliers, and wire strippers. It also includes using a properly calibrated multimeter to test for voltage and current. Using improperly rated tools and equipment can increase the risk of electric shock and other hazards. Moreover, proper wiring techniques are essential for ensuring the safety and reliability of electrical installations. This includes making sure that all connections are tight and secure and that conductors are properly insulated. It also includes avoiding the use of back-wired receptacles, which are more prone to loose connections and overheating. Instead, use side-wired receptacles, which provide a more secure connection. When working with electrical circuits, it is essential to always de-energize the circuit before starting any work. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Before touching any wires or equipment, use a multimeter to verify that the circuit is de-energized. Additionally, it is important to wear appropriate personal protective equipment (PPE) such as safety glasses and gloves. Safety glasses will protect your eyes from debris, and gloves will protect your hands from electric shock. In the context of commercial buildings, it is crucial to consider the specific types of loads that will be connected to the receptacles. Commercial buildings often have a higher density of electrical equipment and appliances than residential buildings. This can place a greater demand on the electrical system. Therefore, it is essential to carefully plan the receptacle layout and circuit design to ensure that the electrical system can safely and reliably handle the anticipated loads. Furthermore, Commercial buildings often have specialized electrical systems, such as emergency power systems and fire alarm systems. These systems must be installed and maintained in accordance with the NEC and other applicable codes and regulations. It is important to consult with a qualified electrical engineer to ensure that these systems are properly designed and installed. Regarding the specific scenario of using 15 amp receptacles on a 20 amp circuit, there are some limited exceptions under certain circumstances. For example, the NEC permits the use of 15 amp receptacles on a 20 amp circuit if the circuit supplies only one receptacle. This is often the case for dedicated circuits that supply a single appliance, such as a refrigerator or microwave oven. However, it is still essential to ensure that the receptacle is properly rated for the load that it will be supplying. In addition, the NEC permits the use of 15 amp receptacles on a 20 amp circuit if the circuit supplies multiple receptacles and the total load connected to the receptacles does not exceed 15 amps. However, this can be difficult to enforce in practice, as it requires monitoring the loads connected to each receptacle. Therefore, it is generally recommended to avoid using 15 amp receptacles on 20 amp circuits unless it is absolutely necessary. In conclusion, the NEC generally prohibits the use of 15 amp receptacles on 20 amp circuits in commercial buildings. To comply with the NEC, you must either use 20 amp receptacles on the 20 amp circuit or reduce the breaker size to 15 amps if you need to use 15 amp receptacles. It is important to always consult the latest edition of the NEC and follow all applicable local codes and regulations when performing electrical work. Always prioritize safety and ensure that all electrical installations are performed by qualified and licensed electricians. Remember to always turn off power before working with electricity. Also remember to test with a meter before touching anything.